everyone. We're talking about boosting security in IoT with blockchain digital IDs today. I will get started with the presentation, and you guys can save your questions. We can do a question and answer session right after the webinar. So I'll get started. Today, so in a nutshell, before I actually start, we're going to talk about two different topics today: digital IDs, and then is the first topic. The second topic is IoT, and then we'll tie it all up together at the end, and kind of like why there's a massive benefit when the two are combined. So I'll start with digital IDs. Traditional digital IDs, as we all know, are typically stored on a secure chip or in the cloud. A lot of people are able to access these digital IDs through their phones or through other digital devices. In order to verify a person's digital identity, the digital ID is presented to a verifier who can then take a look at it or scan it somewhere and then use it to confirm the person's ID. Blockchain-based digital IDs perform the same functionality, except the functionality is the data is actually distributed. It's stored in a decentralized ledger, and that's where the blockchain part of it comes in. And that kind of makes it more secure, and there's a ton of benefits that is associated with that, which I'll get into in a second. So digital IDs, and from here on out, when I say digital IDs, I'm just going to talk about I want everyone to assume we're talking about blockchain-based digital IDs. The title would get too long on every slide, so I kept it a little short. So the data is encrypted and distributed across a network, and that makes it very difficult to tamper with the data, to edit the data, or do any other unverified activities with that data, unless the user who owns the ID themselves is doing it. Each identity holder has a unique identifier, which is then used to access and verify their identity information. So it works like a regular ID in that sense. Like, it provides the functionality of a regular ID. But it's way more secure than a regular ID. And other benefits are they're more secure than traditional systems, and that's primarily because it's encrypted. And so it uses all of the blockchain-based encryption techniques and encryption algorithms that are offered on the different blockchain platforms out there. And the data is stored and distributed across the network, so it's very difficult for hackers to access or alter that data. Secondly, blockchain-based digital IDs are more portable. So in the sense that users can take their information anywhere and present it from any device. So it kind of makes it like easy to use on the go. Third, blockchain-based digital identities are more privacy preserving. So when you look at ZKP or zero knowledge proofs or other security mechanisms, they can be added as features to digital IDs. A lot can actually be done in this space. It's open to imagination because a lot of these solutions they're in very nascent stages. But think of it as programmable identification. So you can program it to do a bunch of different things. In the sense of like giving permissions that are controlled by smart contracts. So it could be based on like a time-bound permission. Or an event-bound permission or stuff like that. So you can really get complicated with the logic when you think of it. So just think of it as like a programmable access to your identification. And key features and benefits of blockchain-based digital IDs. I think we're going to make these slides available for everyone after the presentation, so you guys can go through this slide in more detail. But in a nutshell, is decentralized, immutability, portability, and privacy, the primary benefits. And we're still talking about digital IDs when we're thinking of like a person, but we're going to take this and we're going to apply it to the world of IoT in just a second. So the Internet of Things is basically just any device that is connected to the internet. IoT refers to the network of physical objects that are embedded with sensors, software, and other technologies. The key here is the technologies collect and exchange data. So when we think of what comprises of the IoT, it could be your fridge, it could be your oven, assuming it's a smart fridge and a smart oven. It could be all the devices in your home that you could control through an app. Like a lot of, personally, I have a couple of air purifiers in my house, which I can turn on and off using my application, using an application that I have on my phone. A lot of people that actually have their entire smart home hooked up are able to control their entire house through different applications. So that's really true IoT in the sense of like all their devices in their entire house almost is controlled by various applications, and obviously that goes through the internet, and then that's how you access it from your app sitting at your workplace or anywhere else. So IoT devices can be used for a variety of purposes. You could monitor environmental conditions, track assets, control appliances, and they can be used to collect data that can be used to improve efficiency, safety, and productivity. Also, they can be like a lot of data can be stored and then recalled using these devices. So a lot of these devices have storage built into it. A lot of devices actually write that data onto an online server for storing. So an example of this would be like a security camera that you have at your workplace or at your house, and you wanna see something that happened 6 hours ago. So that data is usually kind of kept in a server, and then you log online and you're able to see it, maybe through your application or maybe through somewhere else. So IoT has the potential to revolutionize several industries. It can be used to improve the efficiency of manufacturing, safety of transportation. These are just a few examples. The management of healthcare, and there's several more. As the technology develops, we can expect to see even more innovation when it comes to the applications for IoT. So the diagram on the right has a person, and you can see that their house is hooked up. They have a printer, they have a car, they have a bike, they have different things. So and then there's like the real world outside, which has regular weather conditions, and that's not IoT, clearly. Okay, so the size of the industry is massive, but it's about to grow exponentially. There are 7 billion internet-connected devices as of today, probably larger as of this presentation, and this number is expected to grow to 55.9 billion by some estimates by 2025, which is not that far away. It's still in a nascent stage at the moment, but it's going to expand pretty fast. Most IoT devices do not incorporate appropriate identity and access management capabilities. So what that means is that right now, when you have an IoT device, like you could have a toaster, or you could have like a baby monitoring device or something. So they don't have the proper identity management capabilities or security mechanisms. There have been a lot of reports of people using different people's IoT devices to kind of like send messages to someone's server in order to crash it. And the thing is that could be happening at night while you sleep, and there could be hackers from another region kind of accessing all your devices. It doesn't affect your life because your toaster still works the same the next morning. But the thing is, you don't actually know what's happened overnight. So in the current system, when you have IoT devices, you just plug it in, you control it with your phone or another application, and that's that. You don't know the story. You don't know what's taking place in terms of like the you don't have access to the data log. You don't have access to the pins that have been made to it overnight. So the solution that we'll get into kind of helps with that. Interconnected Internet of Things devices and objects must identify sensors, monitors, devices, and manage access to sensitive and non-sensitive data in a secure manner. A lot of IT vendors have begun to offer IoT management systems to address these service gaps. The other thing with IoT devices is that there's no I mean, the market's it's diverse. So there's different companies. There's a whole range of different devices. It's not like there's a one go-to. There are some platforms that are leading. So when it comes to smart home, you have like Google Home or Samsung Home. So you have a few solutions, but it's still not like there's no dominant 3 or 4 players in any space. So it's an interesting time because a lot of those market forces are working, and we'll see consolidation, and we'll kind of see some players come out on top. And eventually, I think there will be a lot of standards that IoT and best practices that IoT devices and companies will implement in the near future. So blockchain-based digital IDs can really help make IoT interactions more secure. And the proposition here is that each IoT device is given a unique identity. So when we're talking about blockchain-based digital identity in the beginning, at the start of this conversation, I was saying we're talking about a person using it, but What we're proposing here is that an actual IoT device, every IoT device, have its own blockchain-based digital identity, in which case you can kind of go in and look at the history of what has happened with that device. You can look at the calls that have been made to it. You can see the data that's gone in, that's gone out, and you can kind of look at like the entire history of what's happened with that IoT device. So digital identities can help secure IoT communication by authenticating, authorizing, encrypting, and auditing data. So that's the technical format of exactly what it'll be doing. And it'll help protect the network from unauthorized access to ensure the data is secure. Also, I'm just going to go back a slide. So when we talk about IoT size, right now what's happening is that we're basically, the primary interactions at the moment are human to device and device to human, which means you're doing something to your cell phone. Your cell phone's giving you some data. You're giving data to your cell phone. You're dialing a number. Your cell phone's like connecting the call. Or the same thing goes with all your devices. So you're turning on your laptop and doing something, and your laptop's giving you output in terms of like something on the screen and sound and the printer. So right now it's human to device primarily, but in the near future, if not already, the device to device communication is going to increase, and that device to device communication is going to grow exponentially. So by the time you have 60 billion or 100 billion IoT devices in the world, you'll have a lot of device-to-device communication, and it'll be so big that you can't really keep track of it. So you're going to have to build systems, networks, other forms of programs to kind of manage that and secure that. And what I mean by device-to-device is, let's say you're getting home and your car sends a signal to your garage that, okay, we're like a couple of miles away. And then your garage gets prepared to open, and then it sends all the devices within your house also talk to each other. So the garage says, okay, time to turn on the air conditioning, time to whatever, like turn on the TV and turn down the blinds. So and then the oven gets ready, and all these other things could happen automatically, which you could have programmed earlier. And the devices they're executing orders that you've kind of put into place. But the device-to-device communication is primarily, there's a lot of that happening. So each device could kind of ping the other devices in the house, and they could all get confirmation that something's happened or something's not happened. If something needs to happen chronologically, so you want something to happen before something else. So you want the AC to be turned on before you want the geyser to be turned on, for example, right? So you could kind of program all that in, and that's all going to be device-to-device communication. So that's communication that we're not like right now. You can handle the communication that you're having with your cell phone or your computer, but when 50 billion devices are going to be talking to each other to some degree, it's going to be hard for human beings to track. So you're going to have programs and algorithms and different systems kind of tracking that, and that's really where the importance of blockchain-based digital IDs come in, because you really need a secure ledger where you can chronologically look at all the data, look at what's happened, and you can audit that data right away. So it's extremely important in the future. So I believe we covered this slide. So industries for IoT blockchain use cases: smart homes, manufacturing, supply chain logistics, freight management, automotives, and locomotives, healthcare, wearables. So these are all just examples of devices that are making life easier, that are making processes easier, because they're inputting data and then they're processing it or doing something with it and outputting their findings. In some cases, they're just saving that data and moving forward. So, but essentially, they're all at risk of being hacked, or they're all at risk of being used for unauthorized purposes by other external hackers or users. Also, just going back, freight management or supply chain logistics, I can give a quick example of an IoT, of how IoT devices would be used. So you could have a sensor on a truck that's crossing a national or international border, and it could say that once the goods have crossed the border, then the insurance provider changes, or the truck driver gets paid X amount of money or whatever. So all those things could kind of be linked to smart contracts. And IoT devices could actually, like, so you could have multiple sensors. You could have, you could program in the trucker's cell phone. You could program in the truck's actual GPS location. You could program in a couple of things. You could program in an RFID sensor that reads it at the border. You could also take a picture and program the requirement for that picture of the truck at that border to be uploaded as well. And then when all four proofs are presented, you could release the payment, or you could you could move it to the next step of whatever the supply chain step is. And you could kind of like release a payment or change insurance providers or whatever else. So you can kind of program that all in, but it becomes possible and it becomes easy to do because of IoT devices. And the blockchain makes it programmable, makes the data secure, and makes it auditable. And you can also put money on the line in terms of like encrypting things, putting it into smart contracts. You can incorporate stable coins or crypto to actually move money around as well. So the two, when they're used together, they become extremely powerful. The supply chain one was just an example, but you can kind of use that across the board. How INX can help? We can help you with building out these solutions end to end. We can build digital ID solutions that are based on blockchains. And we offer help with side chains, choosing the right blockchain, Web3 advisory services. We can help translate logic and processes into code. We can create the checks and measures your project requires. We can also do a lot of testing and make sure everything works properly. Get the right set of smart contracts in place. Integrate on-chain and off-chain oracles for your smart contracts. That's usually very important in some use cases. We can do comprehensive relationship mapping and documentation. We can audit your code, test your code, as I mentioned previously, and provide design side support. We have a fantastic design team based out of Toronto. And launch your project live on a platform. So we can help with all that good stuff. And I will open it up to questions. Just before that, quick conclusion. Digital IDs are a powerful tool. They can be used to improve security and privacy. They're also expected to play a major role in securing the future of the Internet of Things. So with that, I'll open it up to questions. Feel free to just throw your questions up in the chat, or someone from the team could actually Slack them to me as they come in. And lastly, we have some contact information on the screen, so feel free to reach out to me through either of those methods of communication. All right, we have some questions coming in. I'm going to start answering them. Just wait for 30 seconds. All right, so the first one is, are there any potential drawbacks or challenges to implementing blockchain-based IDs for IoT device security? There's some challenges in the sense that it depends on which blockchain you build with. And then faulty code is always a pretty big challenge. So getting that code tested is super important. And making sure you choose the right smart contract is super important. Michael has a question. Do you have anything assisting blockchain? I'm not sure what you exactly mean. Hyperledger, Fabric, smart contracts, tokens, or AVAC. Mike, if you could rephrase the question, I'll be happy to answer that as well. How does a blockchain-based digital ID for IoT device integrate with existing identity management solutions? Okay, so a lot of the current identity systems require some sort of a physical proof. So, for example, when you're entering a building, you might need like a certain QR code or something to get in. Current systems would have to partner with some of those solutions, but a lot of the current systems, we're at such a nascent stage with like IoT and smart home and stuff like that, that I feel like a lot of those companies are looking for solutions, are looking for partnership opportunities. So I think that there is, I think it's a fairly straightforward way where they'd integrate with one another. Potential future developments or advancements that we can expect in the field of blockchain-based IDs for IoT device security. I think there are multiple efforts actually ongoing. For developers specifically, there's a lot of grants out there. There's a lot of blockchains out there. They have different grant programs that want people to build innovative solutions. So if you choose to build an IoT-based solution, we'd love to collaborate with you as well. But I feel like a lot of potential future developments and advancements are going to come from like just a lot of the startups that we're going to see in the near future. We can expect Civic was, I think, one of the first companies to kind of create that whole blockchain-based digital ID. But since then, I think there's been a lot of interest in the space, and there's a lot of other people competing and getting into the space. What measures are taken to ensure the privacy of user information when implementing blockchain-based digital IDs for IoT devices? Yeah, so actually this is a thing I wanted to talk about. Very interesting. So user information, whoever's building the system, they can kind of design how much user information is required. A lot of that user information can be, you don't, like, for example, if you need to authenticate something using your age, or if you need to authenticate something, like let's say you're at a bar and trying to get a drink, all you need to do is just authenticate that you're a real person and you're past a certain age. So the digital ID can be programmed to only authenticate that. You don't actually have to give everything else. You don't have to give your name, your address, your phone number. Like, you don't actually have to give all of that to authenticate who you are. The system could just kind of say, here's the, like, this person's over this age and they're good to drink. So that could be an example. So it really, like, programmatically, you can kind of decide the permissions, and you can decide what data is required where. All right, next question. Blockchain has worked well on Bitcoin, but when it comes to expanding to larger networks, it's had its issues. Yes, correct. Some have used Hyperledger Fabric. Yep. Tokens as well to assessment permissions. Yep. Yeah, we are. I'd love to actually have this conversation offline, Michael. But there are several solutions. There's tokens. There's sidechains to kind of make the transactions faster. There are there's many different solutions. There's like private blockchain deployments as well. So, and then tokens, of course. Tokens are the big ones. So I'd love to have this conversation after this webinar as well. Great question. Were there any more? I feel like there was one more question. How does a blockchain-based digital ID device integrate with existing identity management? And I think we answered that, right? Yep. Regulatory or legal concerns? Yep, that's actually a great question. The regulatory or legal concerns are, so the first thing that comes to mind is GDPR. So I think that's something that we should all be aware of and build in accordance to, especially if you're offering your solution in Europe. So GDPR just kind of gives the person the right to delete all their data, and that's, or at least like, and I'm actually not sure what the exact regulation is in terms of blockchains, because the data in the blockchain might be permanent. So maybe delete the person's, unlink the person's user identity with that data. Maybe that's a solution, but that's a very interesting one. That's something we should look into. But that's GDPR, so that's primarily for Europe. So that's something to look out for. And I think just generally, digital ID or identification based regulation should be followed closely. I think the field is so, like, I think we're at such an early stage that it's not obvious, but these things are developing, and this is something that you guys should really keep an eye out for. Your organizations should be looking out for this. All right, I think that's all the questions for today. Anyone with any questions, please reach out to me over email, WhatsApp, Telegram, LinkedIn. So it's all up there. And thank you for attending. And Michael, great question. Feel free to reach out to me. We can have a chat about this after. And look forward to talking with everyone next time. Thank you.